Okay, now then, these are sort of questions you might have actually seen similar in GCSE, but these may be a little bit harder or considered a little bit harder. So here we go. First of all, need to work out the gradient of each. Now the gradient of this, you know it's y equals mx plus c, don't you? And we're going to keep referring to that. So the gradient of that, m being the gradient of that one's 2. Now for this one, I'm going to have to rearrange. So I get 4y equals 11 minus 2x. So y equals 11 over 4 over half x. 2 over 4 half. Now then, I'm going to compare, just quickly change the colour, this gradient here with this gradient here. If they multiply to make, if their product is a -1, then they are perpendicular. And so if I did 2 times -1/2, I end up with -1. So therefore, my answer is, go back to red, perpendicular. Perpendicular. There you go. All right, so that's the first thing. Second one, find the equation of the line that passes through this. Now, first of all, I've not got a lot of room here, so I'm going to first of all go 6y equals 7 minus 2x. So 6y, sorry, not 6y, I do apologise. So just rub that out quickly. I should get, y equals 7 over 6 minus 1/3 x. Now then, what I'm now going to do is I'm going to put y equals 4. 4 from there. I'm going to put m equals -1/3 from there. And I'm going to put, where are we? X equals -1. Sorry, from there. So I meant y equals -1/3 from there. All right, into y equals mx plus c. Told you we'd go back to it. And so here we go. We get 4. Now, this isn't going to be particularly nice. I can already tell. 4 equals -1/3 times -1 plus c. Now, the whole point of this is to find c. We don't know where it's crossing the y-axis. Okay, so I'm going to be doing, it's going to be 3 2/3, which is 11 over 3. So c equals 11 over 3. I'm just going to check that. 4 minus 1/3. Oops. 11 over 3. And so now, so all I've done is rearrange this to find c. And so I end up with y equals, what have we got? -1/3x plus 11 over 3. Now you could rearrange it so that it looks like that. Now if I was to rearrange that, I would multiply by 3, so I get 3y equals 11 minus x, or something like that. Okay, so there you go. Now then, the last question. Find the coordinate where, and I've written slightly on it, 3x plus y equals 7 and 2y minus 5x minus 1 equals 0 intersect. Essentially what we have here is some simultaneous equations. So I'm actually going to rearrange this and say that y equals 7 minus 3x. All I've done is rearrange this here. And then once I've got that, I'm going to substitute that into there. So here we go. So I've got 2 times 7 minus 3x minus 5x minus 1 equals 0. So I'm going to get, what's that, 14 minus 6x minus 5x is going to be horrible. I didn't check any of the numbers beforehand, purely because I actually expect them to be a little bit horrible, in fairness. So we're going to have 13 minus 11x equals 0. So x equals, what's that, 13 over 11. And then to find y, I'm going to do y equals 7 minus 3 lots of 13 over 11, which equals, and I'm going to have to get my calculator out now, 7 minus 3 times 13 over 11, which is 38 over 11. Okay, so there we go. And so the coordinate where they meet or intersect, I should say, is going to be 13 elevenths, 38 elevenths. There you go. Pretty horrible coordinate, and good luck plotting that, but it is accurate, okay? And lines don't always intersect, and nice coordinates. All right, but ultimately, that's the sort of thing. You've seen all this before. It's just slightly messier calculations. All right.